Good afternoon, evening. It's kind of in between, but hope everyone is doing well. We are in week 10. Holy cow, quarters always fly by. And once again, it's flying by even in, you know, COVID times. So I hope you're being safe and healthy and taking care of yourself and just getting through this the best you can, no matter where you fall on the spectrum of politics or whatever. I just hope that you're doing well for you and your family, and no matter whether you think things should be going a certain way or not, it's difficult for all of us. Um, and I think that's the toughest part for humanity right now is that everything's tricky, everything's tough at times, and we have to find ways to dig down and get through this together and lean on each other a little bit. And so I'm here for you in this class and to help you out in any way I can. And I think a lot of you that have reached out have found that true. And I hope that you continue to reach out and get the help you need from me. So you can't see me on the screen today. I'm just sharing my screen only. So let's look at week 10 here and what we have coming up. We are continuing the nervous system, but specifically we're diving into the autonomic nervous system. So before you kind of focus more on nervous system at large and looked at motor movements, now you're going to dive further into it and specifically look at how our nervous system interacts daily, moments, every second, to maintain our body's homeostatic processes using the nervous system. So autonomic, meaning basically automatic, does it without us thinking. And there's two phases to the autonomic nervous system. There is the sympathetic and parasympathetic. Sympathetic is the part of the autonomic nervous system that they often call fight or flight, but really it's the nervous system that part of the nervous system that excites you, that alerts you, that keeps your body more alert and at a heightness of action. And then parasympathetic is more resting, digesting, your normal daily functions to keep your body functioning at baseline. Both these things work together constantly to maintain what we call autonomic tone. So I'm going to go through what you have to do in this module, and then I'm going to talk a little bit about the nervous system using the PowerPoint slide that's in this module, just to give you a brief introduction, as I've been doing. And people have found these intro videos to be very helpful to set the stage for each week, and I'm going to continue to improve these as I reteach this course each quarter. So I'm always looking for ways to tweak and improve these courses to make them better and better and better, because I feel like my courses are never perfect, and I can always find ways to improve them and make it easier for students. So the autonomic nervous system PowerPoint's up there. I also have a what to focus on for autonomic nervous system. So I took the nervous system outline, and instead of just putting it there again, I clipped out the autonomic portion and I added some notes and detail to it. Not a lot, but just a little bit to get you thinking about certain things and to focus your content learning during this module on specifically the autonomic nervous system. It's really easy to go overboard on autonomic, so really stick to that outline because OpenStax has more than you need, and most places do. The PowerPoint that's on there is really, really good. I'm going to show that to you in a second. It's very got lots of good content. And then your sequence of reading activities are there. Notice there's 4 videos that you can watch and a reading from chapter 15. So work through those. Use your outline as a guide as you're listening and taking notes. And then comparing the parasympathetic and sympathetic activity. This activity is a fantastic assignment that's really going to walk you through how to do how to understand the parasympathetic and the sympathetic. It's not that much different than the outline, to be honest. So this is really going to make you have to dig in and understand this material and understand the differences. And then there's a making sense of the nervous system activity, which you've done these already before. This will kind of help you look at what the nervous system is so far before you head into special senses in week 11. Now, as we take a look at the autonomic nervous system, again, remember the nervous system for autonomic is made up of sympathetic branch and parasympathetic branch. So you have your fight or flight or your rest and digest. Okay. The key thing to understand, I'm going to skip through some of these things, so I apologize. But this PowerPoint's really, really beneficial. Okay, there's just a few things I want to show you. But the key thing to understand is these things are always working together against each other to maintain what we call autonomic tone, which is where you have sensory information coming back to the body, to the brain, I should say, central nervous system, and then you have motor information going back out, and it is targeting your viscera, your body, your visceral organs, to then produce actions to adapt to whatever that sensory information is. So you could have parasympathetic and sympathetic information going out, and those two actions are going to work together or against each other to maintain your body's homeostasis, and we refer to that as autonomic tone. So if I go back up, hopefully I'm not making you sick here. If we look at this image, we have this sensory information, this afferent information that's coming back to your central nervous system, where we have these centers that integrate information, like your hypothalamus, your medulla, your pons, and there's a lot more. They are integrating that information, right? That information is integrated, okay, and then we make decisions in our body, and we don't necessarily make those decisions. Our body reacts to them based on what's supposed to happen. For example, if our blood pressure gets too high, depending on the situation, it might adjust that. If our heart rate needs to be lowered, it'll be adjusted. Our respiratory rate needs to raise, it'll raise it. So there's different things that will occur physiologically. So the sensory information comes back, sympathetic nervous system sends something out via efferent, parasympathetic sends something out via efferent, and those two things then work together to create a response, and that's your autonomic tone. It's the ability of the body to maintain a certain set of standard physiological processes to maintain life in our body, okay, and react to external stimuli. So it's that homeostasis, and it's controlled by our autonomic nervous system in many ways. Now, a couple things I really want to focus on with autonomic pathways is we have this idea of preganglionic and postganglionic neurons, okay? Now, ganglia are these clusters of basically cell bodies, okay, of neurons, where all these cell bodies and neurons interact, okay, and messaging occurs, okay? So you have these preganglionic are neurons that go from the spinal cord to the ganglia, and postganglionic go from the ganglia to the organ or tissue that it's targeting, okay? Now, these are different versus sympathetic versus parasympathetic in terms of where these are located, okay? So the ganglia in the sympathetic nervous system, okay, are closer to the spinal cord. And I'll show you a picture. So the ganglia in the sympathetic nervous system are closer to the spinal cord. And that is right here. You can see how these ganglia are closer to the spinal cord. All right? Now, if we go to the other side, the parasympathetic, the ganglia are actually further from the spinal cord. Okay? So sympathetic ganglia are closer to the spinal cord. Okay? Parasympathetic are further from the spinal cord. So you can see some ganglia here, okay, and you can see some ganglia here. All right, and why is that important? Well, it dictates how long certain neurons are. So you can see that's listed here. Okay, I'm not going to go into detail there, but that's what that's referring to. Now, the other thing that's really important when we look at the parasympathetic versus sympathetic is a type of neurotransmitters that the majority of them use at these sites. Now, we have different neurotransmitters used in the body. A lot of the variations occur inside the brain. When we're talking about peripheral, it's more focused. So if we look at the sympathetic nervous system and the parasympathetic nervous system, the preganglionic neurons all prefer to release or do release acetylcholine. Okay? So preganglionic neurons, both sympathetic and parasympathetic, they're going to release acetylcholine. Acetylcholine is that same neurotransmitter that we talked about in skeletal muscle. Postganglionic neurons, on the other hand, are different. So postganglionic neurons for the sympathetic nervous system, they're going to prefer to release adrenaline, basically, right? They're going to release adrenergic type neurotransmitters. So your norepinephrine or your epinephrine. Okay, and they're going to release that in most cases. The one case they release acetylcholine is at the sweat glands. Okay, parasympathetic nervous system, on the other hand, releases acetylcholine in their postganglionic neurons, and that makes sense because it's more associated a lot of times with the rest and digest. Okay, so those are the two different neurotransmitters. Now, they can interact at the same site. If you see on this image here, there are places where they're interacting in the same site. Okay, they're not interacting in different sites. They're interacting in the same site, which means they're both sending neurotransmitters. So depending on the sensor information we get back and the motor signal that goes out, one neurotransmitter may overpower the other one, right? If I get more sympathetic tone than I get parasympathetic tone, my body's going to be more alerted in that organ, or vice versa. Okay, so it's important to understand that these things are happening all together at the same time, and a lot of times they're interacting with each other, leading to inhibition or excitation of another neuron. Let's see if I have an image of that here. Go a little down further. Yeah, right here. So if we look at a dually innervated effector cell, so it's cell or a tissue organ that's being innervated by multiple types of neurons, here we have an adrenergic fiber and a cholinergic fiber. So cholinergic fiber is would be an example of like a parasympathetic neuron that's going to release acetylcholine. And then over here you have an adrenergic fiber, okay, that's releasing adrenaline is the easiest way to remember that. And it's releasing norepinephrine, okay? And you'll notice we have a alpha adrenergic cell here, and we have a muscarinic cholinergic receptor here, okay? There's just different types of cholinergic receptors, okay? So nicotinic is right here, and that's one that's common in the muscles and the brain and stuff. So in this example here, we have norepinephrine being released, and all these molecules, these neurotransmitters, are floating around in the synapse where all these synaptic bulbs are and these effector cells. And you'll notice that these neurons can interact with other neurons, and that can actually cause inhibition in those neurons. Okay, so they're able to actually shut each other down in an effort to control this cell. And that happens in our heart a lot of times. When we get excited and our heart rate goes up, it's because norepinephrine is targeting our heart. So the sympathetic nervous system is targeting our heart. Okay, it targets the receptors in our heart. All right, and it excites our heart, but while also silencing the vagus nerve. The vagus nerve loses control. It inhibits the vagus nerve by sending neurotransmitters to the vagus nerve, which inhibits its control over our heart, which allows our heart to increase its rate of beating. Okay, and the receptors wise, I have a slide in here that talks about the receptors, the alpha and beta receptors. If you've heard of beta blockers, right? If our body has these beta receptors and norepinephrine and epinephrine bind to them, if we take beta blockers, we're keeping our heart from overworking, right? We're keeping our blood pressure from getting too high, from vasoconstriction happening, from heart rate increases. So when you hear beta blockers, that's what that's referring to. All right. There's a lot of detail in the autonomic nervous system. Make sure you pay attention to it. Hopefully this video was helpful. Make sure you stay on task in this module. Reach out to me if you need help. And I look forward to seeing your great work as you continue out this quarter and head into 242 in January, which reminds me, make sure you're getting registered for the next quarter. Reach out to me if you can't get a hold of your advisor, and I will gladly help. Take care and have a blessed rest of your day.